Alright, class, so I'm sorry that I am not here today. I have jury duty, as the board says, but we are going to continue working. So if you'll get out these notes, the three-dimensional shapes notes, and then flip it over to the back side. We're going to talk about surface area today. So when we talk about this, right, we want to make sure that we understand the difference between a pyramid and a prism. Okay, so on today's notes, maybe on the back side, we're going to be talking about SA formula, that surface area formula. Okay, now the nets over here are not always going to look exactly like this. Okay, so this one could be, 4 boxes in a row. Wait, 1, 2, 3, 4. 4 boxes in a row, and then have like 2 boxes on this on the side, and create this kind of hammer type deal here. Okay, it could look like that, or it could look like this. Okay, but it's 6 squares put together that would form the sides of a cube. Okay, and each one is folded up. Okay, now the real issue is actually the formula. So for a prism, okay, so remember that the surface area is broken up into 2 parts, right? There's lateral surface area, which is the everything except for the bottom, okay, and then there's total. So if we have the lateral surface area for a cube, that's just going to be the perimeter times the height. And actually this formula is the formula for all prisms. Apparently my pen does not want to work because it's been open all weekend. Good thing I have an extra. Okay, so apparently this one doesn't want to work either. Okay, so S equals the perimeter times the height of the prism. Okay, that's the lateral part. Okay, and then we also have to have the area of the base, and actually for a prism it excludes the lateral surface area, excludes the bottom and the top. Okay, so because it says plus 2 times the area of the base. Alright, well apparently I gotta switch to another pen on this one. So 2 times the area of the base. Okay, so, and that's going to be for every single prism except for a cylinder, okay, and sphere, which is at the very, very bottom. Okay, we're going to actually talk about spheres on a different day. We're going to talk about that on Thursday. Okay, along with the volume of the sphere that day. So today we're going to only talk about surface area of prisms and the cylinder. Okay, let me get another pen. All right. So let's do the rectangular prism. Okay, so with this one, again, it's the same formula. S equals the perimeter times the height plus 2 times the area of the base. Okay, so up here, if we need to, let's go ahead and make a reminder for ourselves. P is for perimeter. Lowercase h is for height. And capital B is for the area of the base. Okay, and for all of these, we're going to have to multiply the area of the base times 2 because it covers the top portion and the bottom portion, right? So lateral is literally only the sides going up. On the pyramids, the reason we don't have that is because we don't actually have a top part of a pyramid, right? We only have the base. Okay, so now triangular pyramid, same way. Okay, now on this one, we might be given the, we might have to be very careful here, okay, because there will be a height of the pyramid, or of the triangle, and then the height of the prism. So, let's make sure you can actually see that, and zoom in a little bit more. Okay, so you've got the height of the triangle to find the area of the triangle, and then you've got this, what used to be slant height, okay? It's the area of the side length, okay? And if we imagine the triangle standing up like a water bottle or something, or a well, I say water bottle, I'm talking about like my purple water bottle that's sitting over here by the camera. Something like that. So it's standing up, and the base is still the triangle because that's what it would normally sit on, okay? Or is the special section, okay? All right. So let's skip cylinder for right now since it has a different formula. Let's go to pentagonal or pentagonal and hexagonal, okay, prisms as well. So those have, again, the same formula, but notice here that the area of the base is going to be different on each of these. Okay, and the perimeter times the height is still going to be the lateral surface area on both of these. Okay, and then the 2b is the area of the two bases, right? Okay, we'll do an example in a minute. All right, and then the cylinder. So cylinder is different because it's circular, right? So we've got everything is going to be in terms of pi and r, and then the height of the cylinder itself. Okay, so S equals 2 pi r h plus 2 pi r squared. Now, why do we think that it is going to be 2 pi r squared? Why isn't it just pi r squared? Well, aren't there two circles? Okay, we need to find the area of both circles. Okay, and we need to take the circumference of that circle, which is going to be this length right here, right? That's going to be the circumference because that's going to be what wraps around the circle, and then the height there. Okay, so normally the height's over here on that, okay, but this time it's over there. So if we were actually to orient this where it was rotated 90 degrees, it would actually look like this, right? And we could actually use that to be a little bit better in our descriptions. I'm sorry that it's all funky. I found 2 different images online for these, so bear with me. So those are the formulas, okay? Now, it's going to be very much like the formulas where you get a bunch of stuff, you have to plug it in. You don't have to solve for anything today, okay? We're just practicing. So let's look at the rectangular prism, okay? All right. Sometimes this might also be called what's called a cuboid, mostly because it's like 2 cubes put together, if I were to draw this, okay, or a number of cubes put together, because this is a square and that's a square. But I'm going to go ahead and tell you, I'm going to call this a rectangular prism. This will work for any prism, any type of prism. Some people just want to give you things special names because they have special properties. Right now I'm just trying to get you to do surface area. So let's say this is 15 and these sides are both 7, just to make our lives easier. Okay, so what's the perimeter of the base? Okay, now the base is going to be this part, right? The two, what looks like squares, the 2 squares because we did that, or rhombuses. Okay, so the perimeter, P, is going to equal, well, 7 plus 7 plus 7 plus 7 is, that's right, 28. Okay, and then the height is going to be the 15. Okay, so we've got 28 times 15, and that's going to give us the area of all 4 of the rectangular sides. Okay, the top, the front and the back and the bottom, okay, of this, what it looks like right here, okay. So that'll give us all of those, and then we still need to find the shaded in green part, okay, or, well, the shaded in part, okay. I am using a green marker. Doesn't make sense. Okay, so the area of the 2 bases, well, that's just going to be, so plus 2 times the area of the 2 bases, well, the area of the base is the square. 7 times 7 is 49. Okay, so we've got 28 times 15. 28 times 15 plus 2 times 49. Okay, and you don't have to use parentheses if you don't want to. You can if you do. It'll change it to look like this anyway. And we get 518 would be the surface area. So if I said that this was inches, we'd have 518 inches squared, right? So we'd have to be very careful with this. Once we start doing volume, it will be very different, okay? The formula is actually, I believe, simpler. Yeah. because you just find the area of the base and multiply it times the height instead of doing all this extra stuff. But the surface area formulas are easier to look at as far as, oh, this is 3 rectangles and 2 triangles, and I'm just adding them all together. So if that has to happen, okay, that's what we can do. All right. Now, if it's not like this, we might have to do a little bit more, like we did with that one problem, okay, where it gave us 2 different heights, the pyramid that had 2 different slant heights. But I don't think that'll happen here because this is more controlled on the prisms than it was on the pyramids. Alright, so now let's look at an example for the cylinder because it is different. Okay, so let's see. Let's make the radius be, I don't know, let's do an easy number like 3. And we'll say 3 meters. Okay, and then the height will be something as simple, 7, okay, meters as well. Okay, so now we're just going to take this and plug it into our formula. Okay, so 2 pi times the radius of 3 times the height of 7 plus, I'm going to have to write below it because otherwise I'm out of room. Oh, sorry, y'all couldn't see that. Plus the 2 pi r, so 2 pi times 3 again, but 3 is squared. Okay, so just type this in your calculator, and you will get a number. So 2 pi plus 2 pi. I'm just going to put 9 because 3 squared is 9, right? Okay, and so then I got 188.495, which is actually going to make me round to 188.50 meters squared. Okay, now, right now, it does not matter if you have this 0 in here. When you get to physics, you need to make sure that you are doing what they call significant digits, which means you have to take the amount of significant digits from each thing that you plug into the formula and have the same amount of significant digits as when you end, unless it's multiplication, and then you have to add them. I don't remember exactly. You'll learn it in chemistry, you'll learn it in physics. Make sure you know it by the time you get to physics, because if you don't do it right, you'll mess up and you'll get points taken off, much like you did for rounding in my class. So make sure you know how to round and make sure you know about significant digits. Alright, okay, so this concludes today's notes. Okay, you will have an assignment. The sub will pass it out to you shortly, or maybe she'll do it at the beginning of class. I don't know yet, or he. I don't know who it is. So have a great Monday, and I will see you when I get back on Tuesday.